So under modularity, two key design principles are coupling and cohesion. So as the name itself suggests, coupling, it is a measure of interdependence between the software modules, and cohesion is a measure of how well the modules can work together or collaborate together, or how can we identify modules that can work together to achieve the same purpose. So two modules having the same purpose can be clubbed together. So how many modules have the same purpose? So that is known as cohesion. And coupling and cohesion both are ordinal measurements. That is, they have high and low. High coupling, high cohesion, low cohesion. So let's start with coupling. So the coupling is the degree of interdependence between the software modules, as I said before. So two modules that are tightly coupled, meaning they are strongly dependent on each other. So you have a module M1, module M2, and they're dependent on each other to fetch data or any sort of dependency, then they are tightly coupled. And two modules are loosely coupled means they are not dependent on each other for any fetching of data or sharing of data, anything. So uncoupled modules have no interdependence at all within them. So there's a pictorial representation here. So as you can see, you have an uncoupled modules, and then you have a loosely coupled, and then the highly coupled. As you can see, uncoupled don't have any dependencies, and loosely couples have some dependencies here and there, and highly coupled have many dependencies. So coupling increases from worst to best. So the worst coupling is content coupling, and the best coupling is the no direct coupling. Okay, so from there it is like data coupling, stamp coupling, control coupling, external coupling, common coupling, and content coupling. So totally we have around like 7 coupling techniques. No direct coupling, and then you have a data coupling, and then a stamp coupling, control, external, common, and then the content. So no coupling means there is no direct coupling between M1 and M2. As you can see in the diagram, you have a module M1 and M2, and M1 has submodules M11, M12, and M1 module and M2 module have no relations. So there is no direct coupling. So data coupling. When data of one module is passed to another module, this is called data coupling. So as you can see, here the data variable M11 and M12 have a common data variable. So when one data of one module is passed to another module, it is called the data coupling. And stamp coupling, we say two modules are stamped coupled if they communicate using some composite data structures or data items like structure, objects, etc. So, when module communicate by passing non-global data structures or entire structure to another module, they are said to be stamp coupled. For example, if you take in programming language like C and C++, in C, passing the structure variable in C is known as the stamp coupling, or passing an object in C++ language to another module is known as stamp coupling. And then control coupling, where one module controls another module, or it gives a direction to another module for the execution of instruction, then it is known as control coupling. External coupling, it arises when two modules they share an externally imposed data format or any some communication protocols, or two modules are connected with the device interface externally, communication tools, then it is known as external coupling. Common coupling is they have a global data shared by two modules, M1 and M2 modules. So a global sharing of data is known as common coupling. Content coupling exists if they share code from one module to another module. That is known as content coupling. So the worst is content, and the best is no direct coupling, and the second best is data coupling. Okay. So we have Next core design concept under modularity, that is known as cohesion. So cohesion, as I told, degrees to which the elements of a module belong together. That is, they share a same purpose, so that those functions of the module can be clubbed together. So as I have already mentioned, it is an ordinal type of measurement. That is, they have high cohesion and low cohesion. As in coupling, we saw high coupling and low coupling. So the worst cohesion will be coincidental cohesion, and the best cohesion will be the functional cohesion. Okay, so we have like functional cohesion, sequential cohesion, communicational cohesion, procedural cohesion, temporal cohesion, and logical cohesion. So we have 7 types of cohesion here. So functional cohesion is said to exist if the different elements of a module cooperate to achieve a single function. There are different modules, and in each module there are different elements. So there are certain elements of different modules which club together to do a single function. Sequential cohesion means a module is said to possess a sequential cohesion if the element of a module form the components of the sequence, where the output from one component of the sequence is the input to the next. As the name itself suggests, one gets completed, and that output will be the input of the next module. So that is known as sequential cohesion. Communicational cohesion is if the task of the module refer to or update the same data structure, then it is known as communicational cohesion. That is, two modules update the same data structures. So set of function they defined on an array or a stack, that will have a communicational cohesion. Procedural cohesion is they have a sequence of steps which is known as the algorithm, uh, like an algorithm for decoding a message. So you have a sequence of steps. It is procedural in nature. Those kind of module are said to be procedural cohesion. Example would be a modules having mm, a purpose of decoding a message. So it has a procedural steps. Module 1 will have one procedure, module 2 will have a procedure, but both modules, this function is to decode a message. So those kind of modules is said to be procedural cohesion, uh, because they have a procedure to be followed, a step-by-step structure to for example, to decode a message. Temporal cohesion, that is time based. So let's say all that methods have to be executed at the same time. So those modules are said to be temporal cohesion. So when a module has a function, and those modules functions are associated by the fact that by the fact of time, they are associated by the fact of time, those are known as temporal cohesion. And logical cohesion is for any modules, we will always have an exceptional handling, and all those exception handling will be of same structure, like you will have a try method and you will have a throw method. So all those will perform a same functionality, same logic, that is error handling. So a module is said to be logically cohesive if the elements of the module perform a similar operation. So certain elements will be handling the error handling or exception handling. For all modules, we will be having something called error handling or exception handling. Those are said to be logically coherent. Okay. So for example, error handling, data input, data output. So all those elements of each modules will be logically coherent. Yes. Coincident cohesion is the set of operations are loosely connected in some way, very loosely connected. So those are known as coincidental cohesion. So that is the worst level of cohesion, and the best level of cohesion is functional cohesion. Okay. So quick recap. So we saw coupling, and then the cohesion. Coupling of how well how dependent or interdependence between the modules, and cohesion is how well two or three modules can work together to achieve a purpose. So as you can see, the difference between coupling and cohesion. So coupling is the inter-module binding, and cohesion is an intra-module binding. And then coupling shows the relationship between modules, whereas cohesion shows the relationship within the module. Coupling shows the relative interdependence between the modules. Cohesion shows the module's relative functional strength. While creating, you should aim for low coupling, that is, dependencies among modules should be less. While creating, you should aim for high cohesion, that is, a cohesive component module focuses on single function, that is, single mindedness with less interaction with other modules of the system. In coupling, modules are linked to other modules. In cohesion, the module focuses on one thing. So, mainly, in module we focus on clubbing 2 or 3 modules, or we focus on creating a module with a single functionality, whereas coupling focuses on the intermodule relationship. That is a main difference here. Okay.